Okay, today's class is Introduction to Database Management System. As I've said, we will try to see what is database management system, some of the general aspects of database management system, and in the process we'll try to cover as much as possible. Most probably we will also try to cover, if we have time, then characteristics of the database approach, different characteristics, and then we'll also try to see if we can cover the advantages of database management system. So these are the three things that we will try to cover. Now, databases has become very much part of our life in modern society. That wherever we are, whatever we do, there is always some form of we are dealing with some form of database management system or some form of databases. So if you are going to a bank, withdrawing money, opening an account, or you are making a booking reservation in the airline or in the railways, most probably in the bus. So, or you are accessing online library catalogs, or you are doing some purchase online, or even offline purchase, like you're buying something from the supermarkets. So all of these things, almost everything you do today, it involves some kind of databases. Therefore, database has become so unavoidable in the modern society. So whether we know what is database or we don't know what is database, doesn't matter. But irrespective of knowing how it works, what it is about, we are using databases. So that is how important databases have become. So these database application of database also include other things like multimedia databases. For example, you are accessing your Facebook account, you have a video and you have pictures, images, or you are accessing your YouTube account, you are accessing a multimedia database. For example, you may be given the weather updates, that how much rainfall can be expected, where, or how much rainfall was there in the previous few days or so. All of those things are also stored in a database system called geographic information system. Then there are applications like data warehouses, where all the databases, every transaction or every daily transaction or weekly transaction are being captured and kept as it is before it is being changed. That means database is dynamic. It has to be changed. It keeps on changing. The value keeps on changing. Your age keeps on changing as you grow older. But certain things may remain the same, but there are certain things that keeps on changing. So how much, for example, how much money you have today and how much money you have after so many days. So those things keeps on changing. Data warehouses try to capture all of those things, all of those changes without losing the old values. So therefore, I'm just giving a very brief idea about what data warehouses is. Now, we have other more modern applications like online analytical processing, like you derive something out of a database through online, you give some value or you try to bring in, I mean, with a combination of the existing databases, some analytical processing is done and then you get databases. Then you must have heard about big data, where never thought of, never something which is thought to be unimaginable are being done with the databases. Big data is slightly more advanced than the conventional database system. It is more dynamic. It is more, as the name suggests, it is more larger, and it is more, predictive in nature. So these are some of the applications that databases is used. Then we have real-time and active database technology. For example, like a stock market is real time. It keeps on going, the stock value goes up and down. So those things are databases, and they are updated on real time. Then the application on database search technology are also being used in the World Wide Web. So because of using the database technology in the search and browsing of the World Wide Web, now searching and browsing have become much more efficient. For example, many of us know that the first thing we do before we start browsing or searching anything on the web, probably we go to Google. So Google itself is using database technology. So that is why the searching algorithm is becoming much more efficient. Then, if it is so important, what is it? It is so important that in libraries also we are using. I'm sorry, I forgot to mention that in the libraries we are using database almost everywhere. For example, when you talk about library automation, where you are storing the bibliographical detail of the library collection. Bibliographical detail means author, title, publisher, date of publication, and class number, call number, and so on and so forth. All those detailed information about each and every book or each and every collection is called a bibliography, because those things deals with collection. Deals with books. So that automation, information that we gather at the time of automation is also kept in a database. And then we also have in libraries like digital libraries, for example, where the content itself is being accessible. You can access, you can search, and then you can access the content from the site itself. That is called a digital library. Digital library will give you the full text, the content, the full content. So that itself is being stored in a database system. So in libraries, particularly in libraries, we could not escape the use of databases. Therefore, there is an absolute necessity to understand what is database. Then, what is database? Database is a collection of related data. So I want you to underscore that database is a collection of related data. Now, it is not a random data. That means the data, whatever data we have, has to be related. For example, in a bibliography database, we have author, we have title, we have date of publication, we have place of publication, then we have publishers, etc. So all of these things, when you collect these kind of information, it describes a book. It describes a particular book. So author, title, date of publication, place of publication. Now, if you collect these information for all the collection of books you have in your library, it becomes a related data, because author, title, date of publication, place of publication, and publisher, they are all about what? A particular book. So they are all talking about a book. So therefore, there is some relation. It's not a random collection of facts and figures. Now, coming to what is data? What do we mean by data? What is data? Data is a recordable facts that can be recorded, and which also have some kind of implicit or explicit meaning. Now, when you have facts, but you cannot record it, we cannot say that that is a data, because in order to qualify it as a data, we should be able to record it, because here we are talking data from the perspective of a database system. So therefore, any data that we refer to when we are talking about database system should be something which is recordable. Okay, so then Examples of this fact with implicit meanings are, for example, a student may have a name, roll number, marks, department, uh, and then, for example, you store them in a spreadsheet. So those are, when you store all of these things, name of a student, roll number of the student, marks scored by the student, department of the student, and then you store in a spreadsheet. I'm talking about Excel sheet, for example. So there you have related data. The value name, for example, name is uh, let us say the name is ABC, roll number is 1, marks is sorry, marks is 75%, department is library and information science. So this information is about student name ABC, whose roll number is 1, and then who scores 75% in the Department of Library and Information Science. So that information, these related informations or facts are giving us some kind of information. It is able to, this related data is able to inform us about something. So that is what we call fact with implicit meaning. So a collection of related words, for example, when you read a book, when you read the whole book, those are, the book contains what? A book is simply a collection of related words. There are so many words, but those words are not randomly thrown together, and then we cannot call it a book. But there are these words are arranged in such a way that it makes up a page, for example, or pages of a whole book, and then those itself have some kind of relationship based on that related relation between the words, the way it is being arranged is able to tell us or inform us about something, or inform us about the story, inform us about facts, inform us about so many other things that a book can tell. Now, but these related facts ultimately would not qualify to be a data set. Okay, it will not qualify to be a data set. Why? Unless it satisfies what? It has to satisfy the implicit properties of a database system. So certain properties of a database system needs to be qualified. Then only we can call all of these things that we are talking about, information about students, collection of related words, to become a database. Now, what are those properties of a database? That related information, facts with implicit meaning needs to qualify to become a database. Those properties are, so a database interacts and corresponds with the real world. Okay, this is very important. It interacts and corresponds with the real world. That means you have the real world, you have a reality. I mean, database is not simply a fiction, or I mean, it's not something that we simply create out of nowhere. There is a reality, things that really happen in the real world, and database represents part of that reality. Okay, so database will represent part of that reality. It may not be the whole reality. I mean, we are representing about students, but we are not representing everything about students. We are representing certain information about students like name, roll number, marks, department. So those are some part of students. So, but if you have to represent the whole of students, there are so many things. Who are their parents? Where did they go? What type of clothes they wear? I mean, what are their hobbies? How many hours they spend on studying, and so on and so forth. There's so many, too many of them. But database is corresponding, interacts and corresponds with the real world, but it doesn't represent everything. Therefore, it is this real world also sometimes. I mean, sometimes it is also called that database is database represents the mini world. That means part of the real world. Database is a representation of the mini world. Sometimes it is said like that. So now why we said it has interact and correspond. Now the reality will change. What happened in the real world will change. And whenever there is change in the real world, the database also will have to change accordingly. So that is why we say it interacts and corresponds with the real world. Now we record something in a database and the real world has changed. After 2 days, the student record has changed. For example, the student percentage have gone up from 75% to 85%. So there is a change. So that change has to be reflected in the database system. So that is why we are saying that database interacts and correspond with the real world. Now, a database is a logically coherent collection of data with some inherent meaning. I mean, there has to be some coherence between, among the data that we collect in database itself. Like we said, it cannot be simply a random collection. So it has to be not only logically coherent, but it should also have some meaning in it. So it should inform us about something. That is the second property of a database system. Then database is not simply collected for this. I mean, it's not created for the sake of creating. It is created for the sake of some purpose. It has a purpose. Database has a purpose, and the purpose will have a target group. Database we cannot have a universal database. As of now, we cannot have a universal database. For example, when you have a bibliographic database for the library, you are collecting or you are creating that bibliographical database for an intended group of users. Who are those intended group of users? They are your library users. So database is usually created for an intended group of users. That is why most database systems, database collections have specialized collections. So they specialize. I mean, they have a target group. So that group's interest is kept in mind while creating the database. For example, when we are thinking of library users, we create a bibliographical database. Now, we may not have the price of the book included in the database. I mean, we have author, title, publisher for them to determine which book to select or which book to search for. They may not be interested in the price. That would be the least important thing for somebody who wants to read the book which is in the library, unless they want to purchase it. But if they want to purchase it, they'll be looking at an online database. Then the intended group changes again. So in the library, the users are the intended group of users. Therefore, database is created specifically for this kind of users. Now, database can be any size and complexity. Sometimes the database can be huge in such a way that it contains a whole lot of information, which sometimes quite unimaginable. The size can be so huge and so overwhelming, and it can also be so complex that the complexity, one advantage is a complexity. The database can have a complex collection. So no matter how complex are the real world, okay? How complex are the real world, database is able to represent that complexity. That is what database is about. Then a database can be managed manually, okay? With some limitation, manually we can manage a database with some limitations, and with computerized. So most database systems that we are talking about, when we talk about database management system, we are talking about computerized management of a database system. That doesn't mean that we cannot have a manual database system. We can still have it. But DBMS basically is about a computerized collection of data. Now, what is database management system? I've been mentioning again and again DBMS. So what is database management system? So database management system, or in short, just one clarification here. Database management system are three words. One, database. Two, management. Three, systems. But the short form is 1, 2, 3, 4. We have 4 letters. So sometimes people wonder why this word is not simply represented as D, and why don't we have it as DMS? The reason is a bit historical, because once upon a time, data and data and base were written separately, but later on these two becomes a combined word or a single word, and we call it database. But this acronym still maintains that these two being separated. So that is why we call it, we have 4 letters, DBMS. So now database, what is database management system? It is a set of computer programs. Just 1 minute, let me see if I can change the color of my pointer. I want to change it to the color. Okay, sorry. Okay. Now a database, hold on. Yeah. So a database is a set of computer programs. I want you to underscore this. Always pay attention to this set of computer programs. So database is a set of computer programs. That means it is not as one single computer program, but it is a collection or a set of computer programs. So which is used to create and maintain a database system. So that means that a database is multiple computer programs which is used to create and maintain a database. Okay, so when we talk about DBMS, database management system, it sounds like we are talking about one system only. Yes, it is one system containing a set of computer programs. So that works together as a system which is called database management system. So what does a database management system do? It defines, and then it defines the database, it constructs it, it manipulates it, and then it shares database among the users. Now here I want you to note this again, users and application. The database does all of these things. One, defines the database, construct the database, manipulate the database, share the databases among what? Among not only users, but also application. Now, when we said application, we are talking about computer programs. Okay, so that means that a database is not only meant for users alone, but it is also meant for other computer programs. That means application programs can have access to the database system. So in the real world, what will happen is that in most cases, you'll have multiple applications which is accessing your database system. So not only users, but we have multiple applications accessing the database system. Now, how do we define a database system? We said database has to be defined. So when a database is defined, the data types is defined. When we say data types, I mean the basic data types that you might have come across in the Introduction to Information Technology paper. There you have numbers, characters, strings, and binaries, and years, dates, so on and so forth. All of those data types that you have come across, those things has to be defined. If I say a roll number, So suppose if I'm talking about a student's database, and I say roll number. Now this is one single data, so I have to define roll number will be what? Will it be numbers or will it be some kind of characters? For example, the name will be characters or numbers. I have to define it. So when I define it, I am stating the data types. If I say name will be characters, so name will be all characters, then it is character data types. For example, marks. Marks I said is going to be decimal. So I'm defining the data types. So marks will be decimal values, not characters. So with these marks, calculation, mathematical operations or arithmetic operations can be performed, but you cannot perform on a data type character because these are character, they are not numbers, decimals. So that kind of definition of data types needs to be done. Then the structure of the data types. So what is the complexity? For example, I have just defined one structure here. We have a student, then the student contains attributes like roll number, name, and marks. This is one structure. So that way the structure also has to be defined. Then finally, constraints. This is very important. Constraints, what can be done for what cannot be done. For example, I can say that there is a constraint that the roll number should start, all the roll numbers should start with LIS, for example, LIS 01, LIS 02, but it has to be always starting with LIS. So therefore, you cannot have a roll number without LIS. If you have a roll number, try to enter a roll number without LIS, then the system will tell you there is an error or you are violating the constraint rules. So these kind of constraint also. There are so many constraints, but this is just one example that I'm giving you to understand. Then we also have something called metadata. Okay, this is very important. Now, for a library and information science student, you have heard about catalogs. Okay, I think we are too familiar about catalog. So metadata is something like a catalog. A catalog, but in this case, this catalog itself is data. Okay, it resides with the database itself. So it is a set of data that describes and gives information about the data. So we have a database system. Okay, we have a database system and we have metadata. So this combination is what a database system is about. So everything that is about a database system, just like a catalog, a library catalog describes everything about the book. So everything about the database system is described by the metadata. So metadata describe what is the data type, for example, some of the descriptions are, and what is the structure, and what are the constraints. All of those things will be described in metadata. So that is, in other words, sometimes the metadata is called data about data. Okay. Then we have construction of database. So the process, what is construction of a database? It is a process of storing the database, okay? Storing the database on a storage medium that is controlled by the database system. So construction is, in other words, it's like you are the process of storing. That means the process of you are putting together the data in a storage system. Then we have a manipulation also. Manipulation into retriever. That means you are retrieving information from database. Updates, whenever there are changes, like I said in the previous slides, and when the real world changes, so it has to be, the change has to be reflected in the database, therefore you update it. And then you take reports in the sense that you see, for example, I want to see what is the average mark score by a particular group of students. That is a report. I want to take a print out of how much book has been borrowed and returned. Those things are reports. Then also sharing. Okay, sharing, the simultaneous use of database user, database by the, again, users and programs. So when users and programs can simultaneously use a database system, that is called sharing. Now let us come to the characteristics of a database system. So the first characteristic of a database system is that a database is self-describing. Okay, self-describing. Database system is self-describing. Now, we have mentioned a little bit about self-describing in the form of metadata. Okay, metadata. So the database does not only store data. It does not. It's not simply a dumping ground or a bucket where you dump everything, but it also stores the complete definition of the structure, constraint, data types of a database system. All of those things are also stored. And where is it stored? In the form of a metadata system. So structure of each file, okay, the types, the format in which it is stored are kept in the metadata, as I've said. Then this metadata is used by the DBMS applications. This metadata will use the structure, type, format of data being accessed, and so on. So all of these things are stored. Now, without metadata, any application or any users will not be able to make head or tail of a database system. It will become simply scattered, scattered facts and figures. This metadata is what combines the data which is being stored in the storage medium. So metadata is also used by the database users. Here we are talking mostly about the application, but it's also used by the users for searching, retrieving, and all of those things. Now, I'm just giving a simplified database system environment. If you look at this, you will notice that this diagram has been picked up from this particular book. The book by Sri Ramesh, Nawat Samkan, Fundamentals of Database System, Pearson's New International Edition, PS5. So here you will see that we have database users or programmers, whoever, sometimes it is used by programmers also, the people who are responsible for creating or constructing the database system. Then we have a database system. So after the next, we have database system. So within that database system, you have application programs, queries, okay? Then you have the software, database software. So this database software, software to process query, software to access the stored database. Now you have database. Here you have name of the student. For example, name of the student is ABC. Roll number 1. Then you have 75%. All of those things, the stored data, and then definition of those metadata. ABC means what? ABC means name. Then what data type? It is a character. Then roll number. What is roll number? Maybe alphanumeric characters, for example. Or then what is 75? 75 is marks. So marks is in what format? It is in percentage format, percentage numbers. So this is how data is. It's about database system. As you can see, it is not simply database only, facts and figure only. It has metadata, and it also have multiple layers of software. Software to access the stored data. This is more concerned about how the data is stored and how it is organized, how it can be accessed. Then the software to process query or programs, This is another software which is mainly concerned about processing queries and programs. Then we have application programs. As I said in the beginning, it can be multiple application programs, not only one application programs, but and then we have the query which will be used by the users. Now, if you can see that database itself is a collection of software. So there are multiple software, and it has been separated into different layers. So this itself is an advantage that we will discuss later on. Now, another characteristic of a database system is that it is program data independent. Now, in order to understand this, you have to understand one thing. In a normal computer program, whenever there is a change, there is a change in the data, the program also changes. But in database system, that is not necessary. It does not require change in all programs that access a data file whenever there is a change in the structure of the data file. For example, there is a structural change in the data file. In normal program, conventional computer programs, any programs that access this structure of the data file should also change accordingly whenever there are changes. But in database management system, that is not necessary. Like we said, there is some kind of separation. The environment is such that there is some kind of separation between data and program. Data structures and the programs are not written together. They are separated. Therefore, that advantage is there. So this is possible because data files and the access program, the program and access, are stored separately. They are maintained separately, they are stored separately. So the change in the structure of data file needs to be done only in the description catalog, nowhere else. After this change, whenever, if you change the description catalog, let us say the metadata, okay, if you only put it in the changes in the metadata will be, that will be enough. After this change, whenever the access file refers to data, whenever a program tries to access the data file, it will first access the description catalog. So when it accesses the description catalog, will notice that the change has been there. So accordingly, the program need not be changed. So however, the same is not true where the structure of the files are embedded in the application and access programs. When you have these two combined together, whenever there is a structural changes, everything has to be changed. So database is able to achieve program and data independence by having the data files and the access program stored separately. Now the next characteristic is that database program operation independent. There is another independence. This is particularly applicable to object-oriented and object-relational database systems. Users can define, in this kind of database system, users can define operations. Okay, operation is what? The things or the process or the manipulation, in simple terms, that can be done, or what can be done on the data. What can you do? For example, you can put several marks together and create, and calculate an average. That itself is an operation. Okay, so in this type of database, object-oriented database and object-relational database, they allow that every operations has to be defined. For what operation has to be done on a data has to be defined. So therefore, there is some relation. You have a data, or in object-oriented, the data is also known as objects. You have objects. Then in objects, you define what operation can be performed. What can we do? Simple operation can be update, delete, uh, okay, delete, and so on. So these are some simple operations. So we have to define in that object, update, delete is possible. So we are defining those operations. Now, it is not confined to the simple operations, but these operations can sometimes be very complex. So operation is in two parts. So one is the interface or signature, and one is the implementation or method. Now, interface of an operation includes name of the operation, then the data types of its argument or the parameters. Then implementation of an operation is specified separately and can be changed without affecting the interface. Now, no matter how the operations are implemented, application programs can operate on the data through these names and arguments. These particular separations or these particular characteristics of the object-oriented database allow that uh, operations and programs are not interdependent. Application programs can operate on a data through the name and the argument. So it is not that, uh, I mean, you can call an operation. For example, we have defined an operation in a program. So in another program also, we can call that operation again. So therefore, operation is not embedded in the uh, program itself. So therefore, this is another characteristic of the database system. Then coming to data abstraction. It is the characteristics that allows program and data independence and program and operation independence. So what happened is that DBMS use conceptual representation of data by withholding, please mark this, withholding many details. That means DBMS, as we said in the beginning, is a very complex system. But there is a mechanism where all details are withheld. I mean, it is not hidden. Why they have to hide all the details? Because every time somebody use a database system, they need not see everything, because what they need to see is certain small portion of the database system only. Every time they operate, if we make everything visible, they will be overwhelmed with overflow of information. They will not be able to understand it. Just like you find it very difficult to look for a small house in a big city than in a small village, because information becomes overwhelming, everything becomes huge, then it creates problems for you to operate the system if everything is shown to you. So in order to make it simple, it has many details, it hides many details that are the details that are not of no direct interest to the users. If it is only directly related to the users, then only it shows it. So data abstraction is a data model using logical concepts like objects, properties, and interrelationships to help the users understand the computer storage concept. How the computer stored, the concept of how the computer stored the data, and how every object, when we say object, we are trying to understand, yes, this entity is an object, this object has a property, and these objects are interrelated. For example, student, teacher are two different objects. Student is an object, teacher is an object, university is an object. All three of them have their own property. Student object may have name, roll number, marks. Teachers may have name, department, subject, and so on. And university, and all of it, they are interrelated. Okay, all of these things, this is called a data model. So is called data abstractions. That helps us to understand how the computers, database is stored in a computer system and how it can be managed. Because if the details about how the computers are stored and how it can be manipulated is shown to us, then things will become very difficult. So in order to make it simple and understandable, data abstraction is used. However, I know that some of the characteristics like this program data independence will be a little bit difficult for you because you have no programming experience. Then program operation independence is also a little bit difficult to understand because we have not done these object-oriented database models. When we do that, it will become much easier to understand. Then data abstraction, of course, eventually we will discuss things in detail. Now, the other characteristic of database is it allows multiple views. Now, a database has multiple users requiring multiple views. When I say multiple views, for example, imagine that this is a box. Now, this box is a database system. Some people requirement is to see this phase one. Some people's requirement is to see phase two. Some people requirement is to see this phase three. So in other words, this particular database has three facets as far as this drawing is concerned. It is multifaceted. So for one user, he or she requires to see only this, to view only this. The other one needs to view only this. The other one needs to view only this. So database is such that it allows part of the database, okay, or a virtual view to be derived from the database file, and it allows the users to see different views accordingly. For example, you want to see who are the authors. You want to see authors only in a bibliographical database. That is one type of view. Or you want to see the books which is bought, which is published in 2020. Then that is one type of view. So you are searching a book and you want to see something, some books on COVID-19, for example. Then all the books on COVID-19 will be listed. That is one form of views. So it allows multiple views by having some part of the database or having a virtual view derived from the database file itself. So most database management system defines and support different views. So that is another characteristic of a database system. Then the next characteristic of a database system is that sharing and multi-transaction. So multiple users are allowed to access the database at the same time. Okay, that means more than one. So many users can access the database at the same time, the same minute, at the same hour, the same second. Now, chances are that, for example, here, this person wants to put 1. This person wants to put 2. This person wants to put 3. So here, they all want to make changes in this particular space. Now, what happens is that if all of them are doing it, then there has to be some problem. For example, some kind of contradiction will be there because all of them have different values, but they want to change it. They want to update in or input in the same place. So some kind of control mechanism is required. So that is possible through what we call concurrency control. So this is a software that ensures that the results, when several users update the same data at the same time, that the results, maybe the last one or the results are not classic, okay? They are not contradicting. Example, for example, in reservation, airline reservation or railway reservation, a travel agent, several travel agents may assign a seat. Let us say these are travel agents. These people are travel agents. And they are using the same software. Let us say this is Air India. They want to book it. So 1, 2, 3 are travel agents. So this person, they want to book a ticket for several. This seat number, let us say, is B1. I don't know what is whether it is correct seat number. But B1, all of these travel agents want to book this because they find that this is empty. Now, what happened is that all of them cannot get this book. If all of them get, all of them cannot get this seat, which is shown as empty. Now, if all of them are getting this seat, then what will happen is that three different passengers will be allotted the same seat. So, in order to avoid that kind of problems, we have concurrency control software, as I said earlier. So what happened is that only out of these three, one of them will be able to book this seat, because this is only for one passenger only. So that is the example. Then a transaction is an executing program or process. One has or more database access in the form of reading or updating of the database. So each transaction is executed correctly without interference from other transactions, even when you are accessing the same the same data value. There should not be so much of interference. So there are some of the advantages of a database system. So we will discuss about these advantages in the next class. So today, that will be the end of our session. In the next class, we will discuss what are the advantages of using database